The cross product. If A and B are two vectors, then the cross product of A and B is the vector A cross B with the first row as unit vectors I, J, K. Second row, vector A, A1, A2, A3. Third row, vector B, B1, B2, and B3. In the next exercise, we'll see how to expand this one. So this is called cross product A cross B or vector product. Here are some important results. I cross j is equals to k, j cross k is equals to I, k cross I is equals to j cross I is equals to minus k cross j is equals to minus and I cross k is equals to minus j. Example, if A is equals to 1, 3, 4 and B is equals to 2, 7, minus 5, find the cross product A cross B. So first row I, J, K, next row A, which is 1, 3, 4, and next 2, 7, minus 5. How to simplify this? For I component, 3, 4, 7, minus 5. Minus for J component, 1, 2, and 4, minus 5. Plus for K component, delete this and this, 1, 3, 2, 7. Now how to solve the determinant? 3 times minus 5 minus 7 times 4 I minus 1 times minus 5 2 into 4 j plus 1 into 7 minus 2 times 3, simplify it and we'll get minus 43I plus 13j plus k. Theorem: the vector A cross B is perpendicular or orthogonal to both A and B. If A vector and B vector are on plane x, y, then A cross B is perpendicular to both A and B. If theta is the angle between them, then the length of A cross B is equal to length of A times length of B sine theta. Two vectors A and B are parallel if and only if A cross B is equals to 0 and A and B should be non-zero. Find the cross product A cross B and verify that it is orthogonal to both A and B. First find A cross B. To prove it is orthogonal to A and B, A cross B dot A should be 0, A cross B dot B should be 0. Try these 4 questions yourselves. Find a vector perpendicular to the plane that passes through the points P, Q, and R. P, Q, and R lie on the plane. So first find vector PQ. Q minus P. Minus 2 minus 1, 5 minus 4, minus 1 minus 6. Simplify it, we'll get minus 3I plus J minus 7K. Now find PR. 1 minus 1, minus 1 minus 4, 1 minus 6. Simplify it will get minus 5j minus 5k. Now the vector PQ cross PR is perpendicular to both PQ and PR by definition of cross product. So we find PQ cross PR. First row IJK, second row minus 3, 1, minus 7, third row I is 0, so minus 5 and minus 5. Simplify this with respect to first I. 1 times minus 5 minus minus 5 times minus 7 will get this minus j minus 5 times minus 3 15 0 times minus 7 0 j plus k, delete this and this, minus 3 minus 5 15 minus 0. Simplify it will get minus 40I minus 15j plus 15k. Find the area of triangle with vertices P, Q and R. So from the previous question, we have PQ cross PR, which is minus 40, minus 15, and 15. The area of a parallelogram with adjacent sides PQ and PR is the length of this cross product. Minus 40 squared plus minus 15 squared plus 15 squared, simplify, it will get 5 into root 82, and the area of triangle is half of this one, means 5 into root 82 divide by 2. Vector equation of line R is equals to R0 plus TV, where R0 is a point, V is a vector parallel to the line L, and T is a scalar. X, Y, Z is R. If we simplify this, we'll get x0 plus ta, y0 plus tb, z0 plus tc, where a, b, c is v. Parametric equations are x is equals to x0 plus at. The first one is x, second one is y, and the third one is z. Symmetric equation of line x minus x0 over a, y minus y0 over b, and z minus z0 over c. If we solve this equation for t, we'll get symmetric equation of line. Find a vector equation and parametric equations for the line that passes through the point 5, 1, 3 and is parallel to the vector I plus 4j minus 2k. So we have a point 5, 1, 3 as R0, or we can say 5i plus j plus 3k, and v is equals to I plus 4j minus 2k, which is parallel to the equation of line we have to find. So R is equals to 5i plus j plus 3k plus t into direction I plus 4j minus 2k. Simplify it, 5 plus 1 ti plus 1 plus 4 tj plus 3 minus 2 tk, write in components of I, j and k. So now the parametric equations are x is equals to 5 plus t, y is equals to 1 plus 4t, and z is equals to 3 minus 2t. And to find other 2 points on the line, we replace t with 1 and replace t with minus 1. You can get the answers after replacing these. Find parametric equations and symmetric equations of the line that passes through the points A and B. We don't have a vector parallel to the line, so we observe that the vector v, that is AB, is parallel to the line. So AB is equals to v, which is 3 minus 2 minus 1 minus 4 1 minus minus 3. We will get 1 minus 5 and 4. So the direction numbers are A is equals to 1, B is equals to minus 5, and C is equals to 4. We take the first point, 2, 4, minus 3, and assume it as x0, y0, and z0. Parametric equations are these. So put here all the values. We'll get x is equals to 2 plus t, y is equals to 4 minus 5t, z is equals to minus 3 plus 4t. Now to find symmetric equations, we solve these equations for t. We'll get t is equals to x minus 2, t is equals to y minus 4 over minus 5, and t is equals to z plus 3 over 4. And we'll get our symmetric equations as x minus 2 over 1, y minus 4 over minus 5, z plus 3 over 4. Part B. At what point does this line intersect the xy plane? To find the intersection, we put z is equals to 0 in the symmetric equations, and we'll get x minus 2 over 1, y is equals to y minus 4 over minus 5 is equals to 3 over 4. In here there was z, and we have put it 0. Now simplify this one, x minus 2 is equals to 3 over 4. Solve it for x, and we'll get x is equals to 2.75. Similarly, y minus 4 over minus 5 is equals to 3 over 4. Solve it, we'll get y is equals to 0.25. So The line intersects the xy plane at 2.75, 0.25 and 0. Planes. This is called vector equation of plane, where n is normal vector a, b, c, r is x, y, z, and r0 is x0, y0, z0 point on the plane. This is called scalar equation of the plane through the point x0, y0, z0 with normal vector a, b, c. And this is called linear equation of the plane in x, y, z. So to find the equation of plane, normal vector into point on the plane. Find an equation of the plane through the point 2, 4, minus 1 with normal vector n is equals to 2, 3, 4. So how to find the equation of the plane? Ax minus x0 plus b, y minus y0 plus c into z minus z0, where a, b, c is normal vector. So here we have a is equals to 2, b is equals to 3, c is equals to 4, and x0 as 2, y0 as 4, and z0 as minus 1. Put all these values here. 2 into x minus 2 plus 3 into y minus 4 plus 4 into z plus 1 is equals to 0. Simplify it and we will get the equation of plane as 2x plus 3y plus 4z is equals to 12. Find an equation of the plane that passes through the points P, Q, and R. To find the equation of the plane, we need a normal vector and a point. So to find a normal vector, the vectors A and B corresponding to PQ and PR. First we find PQ, that is A, which is Q minus P, 3 minus 1, 2, minus 1, minus 3, minus 4, 6, minus 2, 4. Now B, which is PR, so R minus P, 5 minus 1, 4, 2 minus 3 minus 1, 0 minus 2, minus 2. Now to find the normal vector, n is equals to A cross B. So first row is I, J, K. Second row is A, 2 minus 4, 4. Third row, 4 minus 1 and minus 2. Solve the determinant. We'll get 12i plus 20j plus 14k. So we have taken the point P1, 3, 2 and the normal vector is given here. So the equation of plane will be x minus 1, y minus 3, z minus 2, and a is 12, b is 20 and c is 14, and we have placed all the values in this formula. So this is our required equation of plane. Find the point at which the line with parametric equations x, y, z intersects the plane 4x plus 5y minus 2z is equals to 18. To find the point of intersection, replace x, y, and z in the equation of plane. So 4 into what is x? 2 plus 3t plus 5 into minus 4t minus 2 into 5 plus t is equals to 18. Solve it as linear equation and get t is equals to minus 2. Now put this value of t in the parametric equations and we will get our point of intersection. Find the angle between the planes x plus y plus z is equals to 1 and x minus 2y plus 3z is equals to 1. So to find the angle between the planes, first we have to find their normal vectors. A, B, C, 1, 1, 1 for the first plane. And A is 1, B is minus 2, C is 3, and 2 is a normal vector for the second plane. Cos theta is equals to n1 dot n2 over length of n1 into length of n2. So we already know how to do the dot product. 1 times 1, 1 times minus 2, 1 times 3. Length of n1 is 1 plus 1 plus 1. Length of n2, 1 square 1, minus 2 square 4, 3 square 9. Simplify it, we'll get 2 over root 42. Theta is equals to cos inverse of 2 over root 42 and we'll get 72 degrees. So 72 degrees is the angle between the two planes. Recommended reference book or textbook for this course is Calculus Metric Version 8th edition by James Stewart. This is the end of the lesson. Thank you.